We are going to do another interesting thing. Let's compare how the ferrous ion solution differs from the ferric ion solution when it comes to reactions. You see, first and foremost, the ferrous ion solution is pale green in color, while the ferric ion solution is yellow brown in color. They both react with aqueous ammonia or hydroxide ion solution to form their respective hydroxide. The ferrous ion forms ferrous hydroxide FeOH2, which is dirty green in color. It's dirty green in color. While the ferric ion forms ferric hydroxide precipitate, which is red brown in color. You can add an oxidizing agent like hydrogen peroxide into the ferrous hydroxide precipitate and it will oxidize to ferric hydroxide, and vice versa. You can reduce ferric hydroxide into ferrous hydroxide using a reducing agent like zinc dust. Both hydroxides are insoluble upon further addition of both ammonium and hydroxide ions. If one were to heat ferric hydroxide, you will get ferric oxide, which is also red-brown color solid. Both ferric and ferrous ions, they both react with excess chloride ion. They both react with excess hydrochloric acid to form their respective chlorocomplexes, like so, which are both yellow color. Now here is where it gets very tricky. Both the ferrous and the ferric ions react with cyanide solution to form their respective complexes. When the cyanide ion solution is added to ferrous ion solution, it forms a yellow-green color ferrocyanide. It's ferrocyanide because the ion here is in +2 oxidation state. While here, if cyanide ion is added into ferric ion solution, we get a brown color ferricyanide because the ion is in +3 oxidation state still. Yellow-green ferrocyanide, brown ferricyanide. Now here it gets very tricky. Now over here what we see is a compound known as potassium ferrocyanide, while here we have a compound known as potassium ferricyanide. Now let's react the ferrous and ferric ions with each of them. If we were to react ferrous ion solution with potassium ferrocyanide, we get this white color complex. K2FeCN6. If we were to add the potassium ferrocyanide into the ferric ion solution, it makes a Prussian blue complex, which is as though KFeFeCN6. If we were to add potassium ferricyanide into the ferrous ion, it forms a Turnbull blue color solution complex, which is as though KFeFeCN6. And if we were to add potassium ferricyanide into the ferric ion solution, we get this brown color complex, FeFeCN6. As you can see, I have added the oxidation states of each of the ions in these complexes. As you can see, Prussian blue and Turnbull blue both have the same formula. What makes them differ is the oxidation states of the ions. They have like interchanged, as you can see. If we were to add carbonate ion solution into the ferrous and ferric ion solution, the ferrous ion solution shows no observation, while the ferric ion solution forms carbon dioxide. Here's a unique reaction of Fe3+, of the ferric ion. If we were to add salicylic acid into the ferric ion solution, we get a purple color solution. Another unique reaction of of the ferric ion solution is that if we were to add thiocyanate ion solution into the ferric ion solution, we get a blood red solution which consists of these complexes FeSCN2 plus, FeSCN twice plus, and FeSCN thrice. And as normally, you can oxidize ferrous ion into ferric ion using an oxidizing agent and reduce ferric ions into ferrous ions using a reducing agent. For those who are interested, salicylic acid is basically benzoic acid with a hydroxide in the ortho position, and this is the differences between the chemistries of the ferric and the ferrous ions.